Hi, I am Marta Casadesús, Project Manager at AEI Textiles, and I will introduce you to textile materials and their innovative possibilities. This content is developed by AEI Textiles in the framework of the Destex project. From its origin, humans had the need to dress, and as a result of this, the first clothes are born. This R&D enabled the development of new fabrics that have facilitated or made possible tasks that previously could not be carried out. The main goals of this lecture are to explain the textile process and to discuss the fields of application of the fabrics. Thus, we will start with an overview of the textile sector, its processes, and then we will deepen on what are the main applications of functional fabrics. This lecture covers the fundamentals and the needed background about general textile materials and complements the different lectures of Destex virtual training. These are the knowledge and competencies you will take out of these lectures. But let's start from the very beginning of the process, talking first about the textile materials and also having a general overview of the textile process. The textile process begins with the fibers, which come from different sources. Those fibers are transformed into yarns through the spinning process. The next process is creating the textile structure, combining different yarns to make fabrics. This could be done by weaving, knitting, or through non-woven processes. Lastly, the fabrics must be finished with the different processes such as dyeing or other chemical or mechanical processes. In this diagram, which is in pages 7 and 8, you can see the general process that a fiber needs to follow in order to become a fabric. These are several paths the production processes can take depending on the kind of fabric and its final use. Let's see every process step by step. Starting for the textile materials. A textile fiber is a solid with a cylindrical structure, macroscopically homogeneous, characterized by its flexibility, small cross-section, and a high length-thickness ratio. They are used in raw material to obtain textile materials. Depending on their origin, fibers can be classified in two main groups: natural fibers or man-made fibers, which can be artificial or synthetic. In order to obtain a man-made fiber, a chemical process is needed in order to transform the raw material. Then, through a mechanical process, the yarns are formed. On the other side, natural fibers do not need a chemical transformation, besides some cleaning in order to process them into yarns. Both kinds of fibers can be processed using the same spinning processes as natural fibers. The general process that a natural fiber needs to follow in order to transform it into a yarn, it's called spinning, is summarized in this diagram. Once we have the yarn, there are several parameters that characterize it. Those parameters are raw material, the yarn count, the twist, if it's dyed or raw, and the play number. Once we have yarns, we can use them to make larger structures such as fabric, or for auxiliary applications such as braiding or sewing. Woven fabrics are any textile formed by weaving. Woven fabrics are often created on a loom and made of many threads, woven on a warp and a weft. Depending on the way the yarns are intertwined, there are three major families of woven fabrics: plain weave, as seen in A, twill, as seen in B, and satin, as seen in C. Knitted fabric results from knitting, the process of interlooping yarns. Its properties are distinct from woven fabric. The key difference is the flexibility knitted fabric have. In the weft knitted fabric, the yarn is fed horizontally to form rows of loops which are individually locked vertically with a corresponding loop in the next horizontal row. In the warp knitted fabric, the yarn zigzags along the length of the fabric. Non-woven fabrics are broadly defined as sheet or rope structures bonded together by entangling fiber or filaments, any by performative things mechanically, thermally, or chemically. They are not made by weaving, knitting, and do not require converting the fibers to a yarn. In order to achieve the right specs for the final products, either yarns fabrics need some treatments or finishing. Let's understand which kind of processes are out there. Textile finishing processes convert fabrics into a usable material that has certain characteristics. A finishing process provides fabrics with characteristics to improve its look, performance, or hand feel. It also includes dyeing and bleaching processes. In order to achieve the desired color, performance, or feel, more than one finishing process is often needed. There are many finishing processes, but we can divide them in three categories that we will see in the next slides. First one, dyeing. Dyeing is the process of applying color to fiber stock, yarn, or fabric. Fabrics can be dyed using different methods and dye stuffs depending on the desired final aspect and the nature of the fibers. On the other hand, printing is a process of decorating textile fabrics by application of pigments, dyes, or other related materials in patterns. Currently, textile printing is a process that is on the rise thanks to its versatility. Mechanical finishing processes are those operations in cloth finishing which owe their effectiveness to the application of agencies such as heat, pressure, and moisture, and not to the interaction of chemicals with a constituent fiber of the fabric. Other finishing examples are lamination and coating. Lamination consists in bonding of pre-prepared polymer film on membrane with one or more textile substrates using adhesives, heat, or pressure. Coating, on the other hand, is the process of applying a viscous liquid, fluid, or formulated compound on a textile substrate. The combination of the different stages explained, starting from the fibers and ending in the finishing processes, will produce a certain kind of fabric that will be adapted to specific functionality it has to accomplish. We can find textiles everywhere, and this happens because the broad functionalities that fabrics can have. Those can be applied to not only in fashion, but also in every industrial sector. Textile materials can be designed accomplishing aesthetics functions, but also security, comfort, environment preservation, etc. Therefore, fabrics can be functionalized to meet the demand of different sectors, and this is achieved through technology, and research. Now, let's look at some functionalities a product can have. When we choose our garments, we are choosing them for its aesthetics, they describe ourselves, for its functions, depending on the weather, etc., and for social expression. Nevertheless, a fourth statement is included nowadays on the described ones, ethics. Apart from being comfortable, functionalized, fashionable, and describe yourself, a garment has a fabrication process and is made with materials that can harm or not the planet, socially and environmentally speaking. So, fabrics are acquiring new individual and collective needs and values. Home textiles are another big market for the textile sector. We can find fabrics in different places at home providing different uses. In this case, the aesthetics function is not so important, but functionality is. Fashion and home textiles are the most common in our day-to-day life. However, fabrics can play a very important role in the technical sector, where they have a high functionalization. In this case, the technical specifications are of great importance. Let's see some examples. There are textiles for civil engineering, agriculture and fishing, architecture and welding, also in automotive packaging and goods of transport, sport and leisure. There are also textiles for environmental protection, home and public buildings, also for technical garments. Thank you for your attention. I hope you learned a lot during this lecture. You can download the presentation to continue deepening your knowledge about textile opportunities. Hope to see you in the next lectures.